Hi guys, we are going to take a look at this question where we have a hovering rescue helicopter and it has a container of supplies with a weight of 1960 newtons and it's hanging from this cable, and the tension in that cable is 2100 newtons. State Newton's first law of motion. A body that is at a state of rest at constant velocity will remain in that state of rest unless a non-zero resultant force acts on it. 3.2. Draw a labeled force diagram and show all the forces acting on the container. Please guys know the difference between force and free body diagrams. For a force body diagram, you will draw a block. For a free body diagram, you will just draw a dot. And they want the block, right? So 3.2, they want the block. All right, what are the forces acting on this block? Definitely the weight, the gravitational force. Then remember there's tension. In this case, tension will be a little bit longer than weight, right? Because it's being pulled up, right? So tension is upwards. But then there's also force from the helicopter. So the force of the helicopter, the blades acting on the container. Okay. And you will get 3 marks for each arrow in the correct direction, correct length. 3.3. Why does the container remain stationary despite the tension being greater than the weight? Because there is an extra downward force on the container. Do we see there? There's another downward force on that container besides weight. So the downward forces are actually greater than the upward forces, and that is why the container remains stationary. Now, the winch inside the helicopter starts to pull the container upwards with an acceleration of 0.13 meters per second square, while the helicopter remains in its position. 3.4. Calculate the mass of the container. All right, so they give us the weight. The weight is 1960, right? 1960. What is the equation for weight? Weight is m times g. So they want the m. We have the g. The g is constant, 9.8. We do our little math equation, and our mass is 200 kilograms. All right. 3.5. Calculate the magnitude of the tension in the cable while the container is being pulled upwards. We know we have to use F net. F net equals to MA, Newton second, guys. So our F net, we have tension. Remember, we have tension. We also have weight. We can call it FG if we want to. And then we also have that force of the blades, right? So F net will be all your lines here. That's your F net. And that will be equal to your MA. So now let's jot in the ones that we have. So we have FG, MG, W, whatever you want to call it. That is 1960. And the force of the blades. The force of the blades is 140. Our mass is 200. And our acceleration has been given there. It is 0.13 meters per second squared. Right, we do our little math equation and we find our T, and our tension is 2000 guys, 2126 newtons. Finish and klar. All right guys, hope that made sense. See ya.